Okay, so word problems, we've got a 5-step process here. So step 1 is to read the problem carefully. So you need to determine what you're looking for, what the question is asking you for, what answer you're trying to solve. Figure out what you know and what you don't know, and the items that you're looking for are what you assign variables to. Make a picture, a figure or table if possible. I do that whenever possible because I find I'm a visual person, so that kind of helps me work through the material and the problem. Step 2 is to write a verbal model, which is an equation in words to describe the given scenario. And so that's where you work with your translating skills from translating math into English. And I have, let me just find this and then kind of paste it in this document. And I will share this document tomorrow. But I have a document with common phrases and what they mean in like the English words and then how they translate into mathematics. So I am going to copy this whole thing into here. And hopefully it copied nicely. It looks like it copied all over the place. Okay. This, it's not even moving. I don't know what it's doing. Okay, let me just undo. Okay. Well, I will take a screenshot of my document instead. That will work. And then I'll paste it into here. Okay. So I have this chart, and it has a list of words that mean addition, subtraction, multiplication, division, and when you have exponents. So when you're in step 2 and you're trying to write a verbal model, you're going to be looking for these types of words to help you translate to take those words and create an equation from them. So you're going to be looking for these words, and then I have on this chart examples of how it would get translated. So that way, if you have this chart handy, that can help you when you're doing the translation part. So step 2 is to create a verbal model. I don't usually write it out in words. I just kind of do that in my head, or I might work out loud to write what the verbal model is. And then I'll write the algebraic equation based off of that model. So steps 2 and 3, I kind of do together. Then step 4, once you have that equation, that's when you are going to just solve. So you're just solving for whatever variable you have. And then step 5, you need to interpret the solution and check that the answer is reasonable. So you want to make sure that your answer makes sense. If you get a number that doesn't make sense, then that indicates to you that you made a mistake either on the solving or you made a mistake in the equation, in writing the equation. If you plug your number back into the equation and it works out, that means that your error is probably in the creation of the equation. So if your answer doesn't make sense, like if you are solving for distance and you get a negative, distance is not negative. We always measure distance, we use positive numbers. So if you have a distance equation and you get a negative number, your mistake is either in the solving, and if the solving works out, then you must have set up your equation wrong. So those are, you want to check to see that your answer makes sense, that it works in the problem. It follows what the problem is asking for. And one general guideline is we always write our final answers as sentences, giving it context. We don't just have our final answer as like x equals 2. We want to say the distance I traveled from point A to point B is 2 miles. So you want to give it some context, you give it units if possible, so that it makes sense in the real world, because that's what we're solving here, our real world problems. So that's the general problem solving model. And so I'm going to do a couple examples. I'm going to pick some from the textbook, some of the odds, or I can do an even from the textbook. Let's see. I'm looking for, here's a good one. Hold on, I'm going to zoom in so we can actually read this. Okay, so Felix and Carlos are two servers at a restaurant. During one shift, Felix made $19 less than Carlos. If their combined total in tips came to $163, how much in tips did each person make? So I read the question out loud or in my head, and I just make sure I read through it. And I've got two people going on here, and we need to know how many tips each person made. So we need to know how many tips Felix had and how many tips Carlos had. So I start by just assigning those variables. So I try to make my letters make sense. And sorry, I'm going to move my keyboard out of the way so I can use my tablet. And don't want to click random things. So I pick F for Felix, and I write down what this means. So this is going to represent the amount of tips that Felix made or got. And then I'll use C for Carlos. And it's always good to indicate your units. So here this is going to be in dollars. So that you remember if you have a distance problem, like are you working with miles or meters or feet, it's always good to just indicate your units and to label what your variables are so that you know what's going on. So sometimes I give myself variables and then I don't need those variables later on, which is totally fine. So I'm looking for the tips that both Felix and Carlos made. And so I've got this sentence, the second sentence that says, during one shift, Felix made $19 less than Carlos. So this entire phrase is something that we can translate directly from English into mathematics. So when you're translating from English to math, you look for where the verb is. So if you have any experience with English, a lot of people who are not good at math say they're English people. So you probably are familiar with verbs, and those are your action things. So you look for where the verb is. And our verb is with the word made. So that is our action happening. Felix made $19 less. So wherever the verb is, that's where your equation, your equal sign goes. So I put my equal sign there. And then to the left, I have Felix. So I'm going to just put F because that's my variable for Felix. And then on the right, I have $19 less than Carlos. So less than indicates subtraction. And so I'm going to just kind of squiggle that. So I'm going to go up to, if I can get this to scroll. So I've got less than on this chart here. So right here, we've got less than. So if you see something like 7 less than t, it gets translated in the opposite order, t minus 7. I like to translate it with a negative, so I would do -7 plus t, and I use that less to tell me that I'm going to have a negative number, and then I put a plus where the word than is. That's how I translate these, so that I don't have to remember that it's in the opposite order. I just see, oh, that word less means it's going to be negative in front. So here, when I see less, that's telling me I'm going to have a negative 19. And then where the word than is, I'm going to put a plus sign. And then I have Carlos. So that is my variable for Carlos. So I've translated this phrase to give myself an equation. Now, if you have two variables, we need to have two equations in order to solve, because this equation by itself isn't going to tell me anything. I need one equation with one variable. So this is where the second sentence comes in. It says if their combined total in tips came to 163. So we've got combined total in tips came to 163. So if the combined total, the word total is a word meaning sum. So we're adding these together. So their total is equal to 163. So I'm taking what's written here and I'm rephrasing it into another equation. So Felix plus Carlos is 163. So I've translated here, and then the next part is how much in tips did each person make. So I have two equations here, and this is what I'm going to do next. I'm going to start with my equation with the sum. When we have problems like this, that is generally where we start. Then I'm going to take my second equation. The second equation is giving us what Felix made. Felix is $19 less than Carlos. I can replace my variable for f with the negative 19 plus c, because f is equal to that. So I'm going to replace f with negative 19 plus c, and then I have plus c, and then I have 163. So by doing that, I now have one equation with one variable, c, that I can solve for. So now is the solving process. So I need to combine like terms. I can add my c's together. So I get negative 19 plus 2c equals 163. So I'm solving for c, so I'm going to add 19 to both sides, because I want to have the c by itself, so I need to move that negative 19 to the other side. So that leaves me with 2c equals, and then 163 plus 19 is 182. So I have 2 times c equals 182. And I need to divide by 2 in order to get c. So when I divide 182 by c, I get 91. So this is the tips that Carlos got. So Carlos made $91 in tips. So I'm writing this in context. I found c equals 91, and I'm writing down what that means. So that means that Carlos made $91 in tips. Now, I want to go back to my question to make sure I'm actually answering what we're asked. So it says, how much in tips did each person make? So even though I know how much Carlos made, I'm not done, because we need to know how much Felix made. So Felix made $19 less than that. So I'm going to go back to my equation that I had made for Felix, the negative 19 plus c, and I'm going to replace c with that 91, because we found out what that is. And so when you subtract 19, that gives you 72. So this tells us that Felix made $72. So I'm going to write that down. Felix made $72 in tips. And now you want to say, does this make sense? So I look at these numbers. They are both positive, so if I had gotten negative numbers for my tips, that probably would have said that that there would have been an error there. But these are both positive. And looking back, if our total is 163, it looks right. And if I add those together, I get 163. I can verify, did Felix make $19 less? Yep, that works out. So I can just check, go back to the original problem, make sure it makes sense in the words, and if it does, then that's your answer. So that's an example of translating. Just kind of zoom out a little bit here so you can see all of it. Taking a word problem and then translate it into some equations that you can work with. And there are a lot of word problems that we have different categories of word problems that we see over and over again. And word problems that involve a total and then some sort of relation between the two things is a very common type of word problem. So anything where you see a total and then you're told that something is 4 times another, or so much, he makes $10 more or something less, those are all solved this same way. You set up 2 equations basically, and you plug one of them into another, and then that allows you to solve for the other variable. And then once you have that, you can go back and find the original. So problems that work like this, just looking at some of the examples in the book, there's like, oh, you have a combined cost for a computer and printer. The computer is $240 more than the printer. You have a hot dog and a soft drink. Soft drink is more than the hot dog. Plumber cuts the pipe into 3 pieces. So even though you have 3 pieces there, it works the same concept. You have relationships between the pieces. You may need 3 equations there, but you get to a point where you can replace them all and end up with 1. So any kind of thing where you have some total and they're working together, those all fit into this same sort of problem. Things with perimeters, you're adding things together. So that's another kind of situation. So all of those fit in the same category. Are there any questions? Okay.
That was very helpful. Thank you for the explanation.
Yeah. So if you guys are good on that, I'm going to do a distance and rate time one, because that was the next one. So those are the uniform motion problems. So let's, if I can get my, there we go. Okay. So uniform motion. These use the equation distance equals rate times time. So d is always the distance. R is the speed or the rate. And then t is time. So with these types of problems, I usually draw pictures just to indicate going back and forth, left or right kind of things, like I just like to draw a picture. So let's see if we can find a good example. Okay, so I'm going to just paste this in. So a woman can hike 1 mile per hour faster down a trail to Archuleta Lake than she can on the return trip uphill. So I like to just immediately draw pictures. So I am going to draw a hill. And so going down is 1 mile per hour faster. And if it's faster, we can think of that as we're adding speed. So I'm going to just put a plus sign there. And then, so she's going faster than she can on the return trip uphill. So I'm going to have the uphill, and I'm going to just indicate that that is slower. Takes her 3 hours to get to the lake. So that the lake is at the bottom. So I'm going to just draw my little lake so I know where that is. So 3 hours going down towards the lake, and then 6 hours returning. And we want to know, what is the speed hiking down to the lake? We don't know her total speed. We just know that she's faster going down to the lake than she is up. So we've got 2 directions here. So we're going to have downhill and uphill. And the distance between these are going to be the same. So the downhill distance is going to be equal to the uphill distance. So I'm going to just indicate that distance for both of these. So if I'm using my distance equals rate times time equations, then the rate downhill and the time downhill needs to be equal to the rate uphill and the time uphill. So when you put letters to the bottom, those are called subscripts, and those act as labels. So I'm just labeling these as downhill and uphill so we don't get confused and think they're the same thing. So once I've set up my relationship, I start plugging in what we know. So we know the time in both directions. So we don't know our rate, but I know that going downhill took 3 hours. And I know that uphill, it took 6 hours. So I can at least plug those in. And then we have these other rates. We don't know the speed down, we don't know the speed up, but we know that downhill was 1 mile per hour faster than uphill. So here's where we can actually write a verbal model. Downhill was 1 mile per hour faster than uphill. So we're talking about the speed here. So the downhill speed is RD, and was is our verb, so that's where the equal sign goes to. When we have 1 mile per hour faster, so that means we're adding 1. I have that plus 1, so I'm going to have a 1. And then just like in the other one where I put the plus sign where the than is, I'm putting the plus sign with the than. And then this is the uphill, that's the speed uphill. So I've written a relationship here that says that downhill was the uphill plus 1 mile per hour for their speed. So now that I have that, I can take where I have RD in my equation and replace it with 1 plus RU. And I'm going to make sure I have this in parentheses because this is RD times 3, and it's not just RU times 3. It's that whole thing that RD is equal to is times 3. And then this RU times 6, I'm going to just rewrite that to 6RU. Now, if some people, they want to get rid of the U at this point and just leave it as R. But I like to leave it with the underscore, the subscript, so you don't get confused on which speed you found. Some people like to use different letters, but then I get confused. I'm like, what were X and Y? You know, I want to keep them as rates, so that's why I use subscripts here. So solving this, on the left side, that 3 is multiplied, so we're distributing. And I know I wrote it the way the equation is written, but you could put that 3 in the front if you wanted. So it's that 3 times 1, which is 3, and then 3 times RU. So that's going to be 3RU. Actually, make that look nicer. And then on the right, we have 6RU. So now we're going to be solving for R, or RU, but we're solving for that variable. So I'm going to be subtracting the 3RU because I want it on the same side as my other RU. And it's less steps if I move that one versus moving the 6. So I'm all about as few steps as possible. So I have 3 on the left, and then 6 minus 3 gives me 3RU. So now I just need to divide by 3. And I get 1 equals RU. So we need to put this in context. So RU is the speed uphill. So I'm going to just write this. The speed uphill was 1, and then we want to include units. So since we were told that our other distance was in miles per hour faster, this is still going to be miles per hour. So the speed uphill was 1 mile per hour. And so we know that downhill was 1 mile per hour faster than that, so that would be 2 miles per hour. So the speed downhill, it'd help if I spelled that right, downhill was 2 miles per hour. And you can just plug that into your equation, what I have highlighted. It's 1 plus 1, you get 2. And that makes sense. Your speed downhill was twice the speed uphill, and so because you're going twice as fast, the time it took was half, because you cut off half the time. That makes sense there. So that's a way to look at it and say, does this make sense? So now the question says, what is your speed hiking down to the lake? So you want to make sure you answer the question. The question didn't actually ask for the uphill, it just wanted to know the downhill. So that's what I'm going to box, that the speed downhill was 2 miles per hour. Are there any questions? I'll kind of... Okay, Amanda says that really helped. I'm glad. So the textbook, it shows these types of problems with the table. And I personally find the table a little confusing. I like to look at it in terms of pictures and then just think about, oh, are my distances equal? And most of the time on these types of problems, you'll have an equal distance or you'll have a total distance where you're adding the distances together. Yeah, the table is where you got stuck. Yeah, I get it. Yeah, because the table, so if I did the same type of problem with the table, and I'll just do this on gray. So they have a table, distance equals rate times time. And so we would have up and down on a problem like this. So uphill, 6 hours, downhill was 3. So then the way the table works, they say, oh, uphill is, they'd say x, downhill is faster by 1. So they put x plus 1. And then what the table does is it multiplies. It's really weird because we usually read left to right, but the table goes right to left. And so if you multiply right to left, you get 6x. And then you multiply and you get 3 times x plus 1. And you see that this is the same as what we got, just with different letters. They use x, I use r. It's the same thing as this, as what this is, and because the two distances are equal, you set those equal. So that's how the table works. But I feel like with the table, you're losing what the actual equation is. You learn like, oh, there's this table, I just plug these things in, but you don't actually see what does that mean. That's why I don't use the table method, and I do it the way that I did on the left. I work with the equations themselves. Now, with mixture problems, I do like the table because I think that's a really great way to do it. But I think for something like distance equals rate times time, it's more confusing than it needs to be. So let's see, so that was about half an hour. I don't like to take too much time because sitting here on a computer for an hour watching somebody talk math can get exhausting, or watching a recording of an hour-long video can be pretty long. But I think this is a good, would this work the same as time equals distance per rate? That is an excellent question, Amanda. So with the table with the distance or time equals distance per rate, the table doesn't really work because of the way it's set up. But yes, you can use the same idea. Like if you have a problem and you know that the times were equal, you can do the same thing where you can set the two times equal to each other. They might have different distances or speed, and then solve. Let's see if there's a example of one that would be a situation like that. Most of the time, let's see. Okay, yeah, here's an example of that. Oh, that did not copy where I thought it was going to copy. So I don't mind doing another one here, just to demonstrate that. That's a good question. So two cars are 190 miles per hour apart and travel toward each other along the same road. So draw a gray road here, and it's my cars, really badly drawn cars going towards each other. And this whole distance here is 190 miles. So I like to really draw pictures. So they meet in 2 hours. So we don't know where they meet. They may not meet in the center. So I'm going to just put a little thing right here. But they drive for the same amount of time. So he drives for 2 hours. Both of them drive for 2 hours. One car travels 5 miles per hour slower. So if it's slower, it's going to be minus 5 miles per hour. Indicate you're subtracting. And I chose on my picture to do the one on the left because if it's slower, it's not going to drive as far. So that's why I labeled the one with the shorter distance as the slower one. So we still have our distance equals rate times time, but in this case, the time is the same. So if you were to solve, you would have distance over rate to get an equation for time. So I can have the time for the slow car equals the time the fast car. And we know that it's both 2 hours. We know they're equal. But we don't know the distances and we don't exactly know the rates. So here's where things are going to get a little tricky if you try to set these equal to each other. So first we've got the distance of the slow car, and then we've got the rate of the slow car. Then we've got the distance of the fast car, or the rate of the fast car. So we don't know their speeds. We don't know their total, we know the total distance, but we don't know their actual speeds here. So I can say, so distance for slow car. Let's just label, let's do this in terms of the slow car here, because I also have, let's do this, let's not do that side. Oops, let's just undo. Let's say that this distance here, we'll just call this x. So then this other side would be 190 minus x. So if I try to write something here, we've got distance for the slow car, which is 190 minus x. And then we've got distance of the fast car, which we called x, just named it. We also don't know the speeds. So if I said that this speed is r, then this other one is r minus 5, because it's 5 slower. So I've got r here, and then this would be r minus 5. So we've got a problem, because right now I've just created myself an equation, and we've got two unknowns. And we have one equation. So we would need a second equation here. So a situation like this with time, and if you end up with a problem where you have two variables in one equation, sometimes it's not best to set those equal to each other. But instead, I'm going to do this in green, do something like the distance of the slow car plus the distance of the fast car equals your total distance of 190 miles. So if we worked that way instead, you'd have the rate of the slow car times the time of the slow car, which is 2 miles, plus the rate of the fast car times the time of the fast car, which was also, oh, I said 2 miles, 2 hours, and then that equals 190. And then based off of my rates, which I had the r minus 5, so the slow is r minus 5 times 2 plus r times 2 equals 190. And now you have something that you can solve. So setting up this way, and instead of setting them equal to, actually is a little bit easier. So if you get yourself in a situation where you're like, oh man, I don't know what to do, I've got too many variables here, try to set it up where you're adding the distances as well. That's not to say that the left side doesn't work. The left side can work. And let's say we wanted to get rid of the x. So hopefully I don't get too confusing here. So for this car, we know it went some sort of distance, we called it x, equals r times 2. So you could replace your x with r times 2 by using that 2 miles. And then you can solve this. But it's a proportion, it's going to be a lot more steps here, because you are going to have to cross multiply. You'd have to multiply these together, and then you would have that equal to the other direction for the multiplication. You'll get the same answer, it's just going to be a lot more steps. So if I actually wrote that, you would have r times 190 minus 2r equals to 2r times r minus 5. Oh, you're going to get into a really nasty thing here. You're going to get into a quadratic, which isn't even something that you've learned about yet. It's solvable. It's definitely solvable in this way, but you guys haven't learned those techniques yet. So my best suggestion is, if you get yourself into something that looks nasty and you're like, wait, I'm kind of stuck, try it, instead of setting them equal to each other, try to see if you can set up something with a total and just do the method on the right. Does that help? Yeah, so definitely solvable with the left side, but it's just not going to be as nice. So I'm actually really glad that, going through the thought process here, because problem solving, especially with word problems, you're not going to get it right the first time. I mean, you can say, okay, let me try this. I know they have equal times. Let's see where I go. And you're going to get to a point where you're kind of stuck. And so then you have to stop and think, well, maybe there's a different way to go about this, and try to change your thinking and see if there's a different way you can set it up. It doesn't mean that your method's wrong. It just means that there might be a better way out there. So problem solving is a lot of trial and error and being able to see what didn't work and then where can I go from here. And out of curiosity, I just want to verify I have a graphing calculator that I can solve stuff for. So I'm just, instead of doing all of that math on the left side that you guys don't know how to do, I'm going to use my calculator to solve it and see what it tells me. And I'm going to make sure that I enter these things in right. Okay, so the one on the left, which uses a quadratic, which you guys don't know yet. So what section will you learn that? Just as a, so that maybe when you get to that section, you can be like, oh, let's try to do this. Let's see. So 3.4. So when you guys get to 3.4 in a couple weeks, you can revisit this problem and try to solve it with this technique and see if you get the same answer. But you end up with two answers. And this is where you ask yourself, well, which makes sense? Two answers. Well, this means speed. This is We said R was for the fast car. So a speed of 0 miles per hour doesn't make sense. But a speed of 50 miles per hour does. So you say, okay, which one of these answers makes sense? So it's probably the 50 miles per hour. And let's go ahead and solve the one on the right to verify that we get the same answer. So the R minus 5 times 2, I need to distribute that 2. So it's 2 times R, which is 2R, and then negative 5 times 2, so that's a negative 10, plus 2R equals 190. So 2R plus 2R is 4R minus 10 equals 190. So I will add 10 to both sides. We get 4R equals 200, which then you divide by 4, and you get R equals 50. So 50 miles per hour is for the fast car. So we do get the same answer. So I just think, you know, if you guys remember in 3 weeks and you're doing section 3.3, revisit this problem and see if you can do it the other way and get the same answer. And let's just double check. Average speed of each car. So I only found the average speed of the fast car, so I'm only halfway there. We need to find the speed of the other car, which is 5 miles per hour slower. So let's just write this answer in a sentence. The faster car average 50 miles per hour. The slower car averaged 45 miles per hour because it's 5 miles per hour slower. And if you wanted to do a table for this problem, you would set it up the same way as the kind of table over here. You'd be plugging in different things, but you'd be adding your distances together in this case instead of setting them equal to like in this one. But I don't like to use the table, so this is how I do it. Are there any questions on this? Yeah, they do use the table a lot in the homework. You could solve it this way, and then when you're doing the homework, if they're asking you to fill in the table, you can just reverse engineer the table. That's what I would do because I find the table more confusing, but I can usually figure out the table once I've set up my equation. So that's what I would recommend, is just kind of reverse it, or set up the table and then don't even use it to solve it and use this way. The table is just filling in what you know, and then it's the X part that's probably the hardest. And if you can figure it out with your R's, just replace R with X and you should get it right. I'm glad that helped. And that cleared up a lot for you. That's why I'm here. So that's why I do these every week. Because, you know, it's nice sometimes that we've got tutor.com and you can help from them, but sometimes it's nice just to have a person that you can, you know, get immediate help with and get a different explanation verbally, maybe not over chat, you know, and just to see things worked out. So generally this works is once I end the recording, I don't usually email them out to you guys until the next day because I have them in the evenings. And when I email them out, they'll go to your Grantham email. I'll put it as an announcement in the classroom. And then I also include any documents. So like this that I wrote on, I'll make as a PDF, and then I'll attach that to the email. So everybody will get an email via an announcement from me And then you can just check your Grantham email address. So that's usually by like 10 a.m. Central Time tomorrow. I usually try to get that out immediately. And I post a recording on YouTube. So I'll also be sharing, I think I forget if I shared that with you guys, the link to my YouTube channel. I did not. So I will make sure tomorrow I'll also give you guys a link to my YouTube channel where I host these, and I have a playlist of algebra videos. So I'll be adding this to there, and then you can also go and look at older college algebra videos that I've created for other classes, other terms, and so that will be a great resource for you guys during the week as well. And I'll be doing this every Monday night, same time. I'll be here, same link, so you can bookmark this link. I try to remember to send a reminder, since I'm not very good at that, but I try to send a reminder, or at least have a weekly announcement emailed to you guys that, like, hey, this is, coming up. I recommend putting it on your calendar. Just put it as a repeating task on your calendar so that you don't forget if you want to be here every week and ask questions and get some help. So that's how this goes. So I'm going to stop the recording here.